Hello everyone, welcome to my civil engineering YouTube channel. Please subscribe to this channel and hit the bell icon to get notified when I post my new videos. Today, I'll be discussing a numerical on how to determine a centroid for a T-shaped structure. So here we have a T-shaped structure wherein the width of the flange is equal to 200 mm. The width of the flange, this is the flange, this is called flange, F-L-A-N-G-E, flange, and this is called web. So this is the web portion, the vertical portion, and the horizontal portion is called as flange. So here the width of the flange or the horizontal dimension of the flange is given as 200 mm. Vertical dimension of the flange is given as 20 mm. Width of the web or the horizontal dimension of the web is given as 200 mm. The vertical dimension of the web is given as 150 mm. So here, as a structure, as a whole structure, we should determine what is the centroid for the overall T-shaped structure. So here, before going to determine the centroid for the overall structure, we need to locate some reference axis. So we need to assume the reference axis. So here I have assumed the reference axis, which is represented by the red dotted lines here. So it is from the origin, it is OX in the horizontal direction and OY in the vertical direction. So here I have taken the reference axis, and reference axis is assumed in order to measure the centroid with the reference to the reference axis. So here I have also mentioned as G1 and G2. So here you can just notice that the overall T-shaped structure can be divided into two rectangles. So one is in the flange area, that is 200 by 20 is the first rectangle. So this is the second rectangle, which is in the web portion. So that is 20 into 150. So now G1 and G2 represents the centroid of the individual rectangles. I repeated, G1 and G2 represents the centroid of the individual rectangles. So first of all, in order to determine the centroid for the overall T-shaped structure, we need to assume some reference axis, and from that reference axis we are supposed to find out what is the centroid for the overall structure. So in order to determine the centroid of the overall structure, it will be a bit difficult. So what we do is we are supposed to divide the overall structure into two parts. So here one is the rectangle in the flange part, and second is the rectangle of the web part, that is 20 into 150 is the web part rectangle, and 200 into 20 is the flange part rectangle. So that first of all we are supposed to determine the individual centroid for the two rectangles, and then we can easily find out what is the centroid for the overall figure. So now here as I said that we are supposed to determine the centroid for the individual rectangle. So here we have assumed two rectangles. One is at the flange portion and one more at the web portion. So this figure represents the centroid bifurcation or centroidal axis for the rectangle at the flange part. So here G1 represents the centroidal point for the individual rectangle at the flange part, and red axis line represents the reference axis, and green dotted line in the x and y axis, or green line in the horizontal and vertical dimension, which bisects the centroidal point, represents the centroidal axis of the rectangle at the flange part. So here we similarly we have the web part here, web part rectangle. So this is the bifurcation of the web part rectangle, which is represented by the green dotted lines. So as we know that the centroid for the rectangle will be determined from the as we know that the centroid for the overall structure will be determined by the individual centroidal axis. So here I have bifurcated, or I have bisected the axis through the centroid of the first rectangle. So wherein the horizontal dimension represents the x1 and vertical dimension is represented by y1 with reference to the overall reference axis ox and oy. So here I need to calculate the area of the first rectangle. So area of the first rectangle is length into breadth. So wherein length is equal to 200 mm and width is equal to 20 mm. So therefore the overall area is equal to 4000 mm square. So next is x1. X1 is for the x1 is the distance between the x1 is the distance between the reference axis to the individual centroidal axis. X1 is the horizontal distance between the reference axis and the individual centroidal axis. So here it is the rectangle section. Hence, x1 is equal to the horizontal dimension divided by 2, or half of the horizontal dimension. So this was explained or derived in the previous lecture series, how I got the value as L by 2. So x1 is equal to L by 2. The horizontal dimension of rectangle 1 is 200. So it is 200 divided by 2 is equal to 100 mm. Similarly, the value y1 is the distance between the vertical distance between the horizontal reference axis to that of the centroidal point of the individual rectangle. So here we know that the overall vertical distance is 20 mm. So but half of 20 will be equal to 10. So until here we get as 10 mm, but our reference axis is until here. So we need to add the remaining distance. So 150 is the remaining distance from here to here, and then 20 by 2 is the individual centroidal distance in the vertical direction. So it is 150 plus 20 by 2. 150 plus 20 by 2 is the value of the vertical centroidal axis, the vertical centroidal distance. So next is for the centroid for the rectangle 2. So similarly we have x2 and y2 here. So first thing, we are supposed to calculate the area A2 here. So wherein it is equal to L into B, where L is the horizontal dimension, it is equal to 20 mm, and B is the vertical dimension, it is equal to 150 mm. So the product will be 3000 mm square. So then x2 is equal to L2 by 2. L2 by 2. Since it is symmetric about the x-axis, so therefore the value remains same as 100 mm. The value remains same as 100 mm. So next is y2. So y2, it is the, as I said that y2 is the vertical distance from the reference axis to that of the individual centroid of the rectangle. So here we have the overall distance as 150 here from from the web rectangle. So here 150, half of 150 is 75 mm. So that 75 mm will represents the vertical distance from the reference axis to that of the individual centroidal axis of rectangle 2. So with reference to the calculation of x1, y1 and x2, y2, we can determine the centroid for the overall T-shaped structure as a whole easily. So that is represented by x is equal to sigma ax divided by sigma a, wherein x represents the horizontal centroidal distance of the overall T section. So we know that sigma AX is nothing but A1 x1 plus A2 x2 divided by sigma A represents A1 plus A2, summation of all the areas of the individual structures, geometrical structures. So we have two geometrical structure, we have bifurcated it as two rectangles, so wherein its area is A1 and A2, so therefore sigma A is equal to A1 plus A2. So after substituting the respective values, we will get the x value as 100 itself. So next, coming on to the y. Y represents the vertical distance of the overall T section with reference to the horizontal axis. So that is sigma AY divided by sigma A. So it is nothing but A1 Y1 plus A2. It should be equal to Y2. So A2 Y2 divided by A1 plus A2. So here after substitution, I'll get the value as 123.57 mm, 123.57 mm. So this represents the overall summary sketch. So wherein if I just draw the overall T-shaped structure, so I got the x that is the vertical dimension, sorry, horizontal centroidal axis distance as 100 mm and vertical distance as 123.57. So if this dot represents the overall centroid, that is G, centroidal point G. So from G to the horizontal axis, reference axis, the value will be equal to y. That value we got it as 123.57, and the vertical distance between G to that of the OY axis, that is a vertical axis, we get it as 100 mm, 100 mm. Thank you for watching. Please like, share and subscribe the video. Thank you.